The motion of the moon, section 4. This is iBooks. This is going to be the last section of this chapter for us. Okay, we're not going to do section 5. We're going to stop at section 4. This is going to be a 2-part lecture, today and Tuesday. Okay, after the long weekend. The moon is orbiting the Earth. So how far does it move? Well, it moves its own width each hour. Well, how wide is the moon? Write this down. It's half a degree wide in the sky. The moon is half a degree wide. I want you to think about how much that is. From horizon to horizon is how many degrees? 180. So how much is half a degree? Guys, it's just about the width of your thumb at arm's length. Look how wide your thumb is. That's about half a degree. That's it. If you don't believe me, the next time it's a full moon and you think the moon is so huge and beautiful, hold up your thumb and you'll make it disappear. It's that small in the sky, just half a degree. So, the moon is moving about half a degree every hour. Well, let's say you wanted to test that out. And you're getting ready to go into the movie theater over here at Magnolia, and you're getting ready to go in, and you look, and there's a full moon rising in the east, let's say. Full, big, beautiful full moon coming up. You go into the movie theater for 2 hours. When you come out, according to this, how far should the moon have moved? In 2 hours, after a 2-hour movie?
2 degrees.
2 thumbs or 1 degree. Now, let me ask you, if you've been inside for 2 hours and you come out, is that how far the moon has moved in the sky? No, it's moved a lot farther than that. Why?
This is far away from us.
Because we've moved. What is the Earth doing during that time period? Spinning. We're rotating on an axis. And we rotate, here's the math, we spin 360 degrees in 24 hours. 360 divided by 24 is 15. So we spin 15 degrees per hour. So after a 2-hour movie, how far is the Earth spun? 30 degrees. So now the moon, instead of being 1 degree above the horizon, is 31 degrees above the horizon. Does that make sense? But 30 of that is due to our spinning, and only 1 degree is due to the moon actually moving. So by far, most of its motion in the sky is due to our own spinning. Yes?
Doesn't that same type of thing have to do with why we can't see the dark side of the moon?
Kind of. I'll get to that later, okay? Good question. I would definitely go over that. What? Yeah, you never have to ask. It passes up there. Okay. Next up. How long do you think it takes to go from one full moon to another? Give me a rough. About 30 days. Good guess. It's exactly 29 and a half from one full moon to the next, or from one new moon to the next. Guys, that's where we get months from. In Old English, moons. How many moons are there in a year? 12, usually, because there are 12 full moons in a year. That's where we get months. That's what a month means, a month. Now, some years you will sort of have, in a calendar year, you'll sort of have an extra moon, a 13th full moon that slips in, and this gets a little complicated, but what do we call that extra moon? No. A blue moon. Has nothing to do with it being blue, but this doesn't happen often, so we call it once in a blue moon, where we get that extra 13th moon that fits in the calendar year. That gets a little complicated, the exact definition. I don't want to get into that, but just know that's basically what it is when you have an extra moon in there. All right. We had astronomy night Tuesday night. It was a new moon. When I say new moon, I want you to think no moon. Because when you go out at night, you are not going to see the moon. And I like having astronomy night when it's a new moon, because then the moon is so bright, it ruins it for other things that we get to see. So we had it on a new moon. Now, a couple days after that, I was riding bicycles with my son right after sunset. And so I knew, okay, the moon is hanging out close to the sun, but after a couple days, I might catch it. And sure enough, we looked to the west right after sunset, and we caught the tiniest little sliver of the moon. Now, since then, the moon has been sort of growing, right? We're seeing more of it. What is it called as it sort of grows during the month? Waxing. It waxes, and then of course later in the month it's going to wane. We're going to go through all the phases right now. And I'm going to show you, I think, through a website, a really nice little website link to show you, remind you of what the phases are and show you why the moon goes through the phases like it does. Yes? It technically does. And this goes to the question he had. It looks like I'm going to have to answer this question now, no matter what. But it rotates at just the right rate to keep the same face always towards us. So it basically rotates once a month. It's a very slow rotation. Good question. Now, this website link I just put into Dropbox. iBooks, I want this link in the iBooks. It's a great thing. You guys will like this. It's kind of fun. And those of you making a website and making an app and so forth, include this. Get into Dropbox and include this link, because you're going to like this little site. I'm going to speed up the rate a little bit. Let's take a look now. So, we're starting out here. It is a really big person, yes. Sun, moon, earth. What phase is the moon?
New.
A new moon. When the moon is between the sun and the earth, it's a new moon, and that's why when you spin around at night, you're not going to see it. Okay? Occasionally, of course, sometimes you can catch it during the daytime at times, but this is not one. You're not going to see it at all. All right? So, let's move ahead in time a little bit here. There we go, round and around. Days are going by. All right, let's go to a couple days after. So we had astronomy night. And then a couple days after that is when my son and I saw the moon looking like this. Right after sunset, okay, right when we got to here, the line between day and night, we were standing there looking out, and we were catching just a little sliver of the moon. Tonight, of course, is the football game. At the start of the football game, what time does the game start? 7 o'clock. Okay, so it'll actually be a little ways into the football game. Around 8 o'clock, the sun's going to set. And then if you look to the west, don't do this during the play. When you look to the west, you're going to see a crescent moon tonight. And it's not going to be up for long. Okay, it won't be up probably even at the end of the game, by the end of the game. But an hour into the game, you're going to see that crescent moon. But of course, it is getting larger. It is waxing. So now we're 3 or 4 days since astronomy night, and it's going to look more like that. Okay, let's continue now. Oh, so close. So close. Tried to get it right on 50 there. Let's see if I can get it right. Exactly 50. Oh, come on.
Like refuses to be 50.
Wow. I apologize. Listen, if you guys want to drop this class, I understand. I really failed you. I apologize. But anyway, look. Does anybody remember from grade school or middle school what this phase is called? No, it's not called a half. It's actually called the first quarter. Now, that's based on the fact if you divide the month into 4 weeks, like 4 quarters of a football game, then after the first quarter, this is what the moon looks like. And 50% of it is illuminated. And this is why we're going out Tuesday night to Liberty Park, because I want the photography teams to get a really nice picture when it's exactly like this, okay? When it looks really nice. First quarter moon, the craters look awesome at that point. And you notice how much time has gone by since the new moon? 7 days. So about a week later, about a week after our first astronomy night, when it was a new moon, we'll see the first quarter. Let's continue. Now when you start seeing most of the moon, what is that called? A gibbous moon. So since it's growing at this point, that will be a waxing gibbous. waxing gibbous, waxing gibbous. See how close I can get. Oh, fail. Come on, I can do it.
Yeah, you got this. I believe in you.
Thank you. Yes,
Yay.
yes. All right.
We did it.
So, thank you for your support. I appreciate that. So, look at that, 100% illuminated. We have a full moon. Take a look. Sun, Earth, Moon. That's a full moon. And how long has it been since the new moon? 14 days, or about 2 weeks. So since we had astronomy night on Tuesday, in a couple of weeks we could have astronomy night and watch the full moon come up. Now on the other side of its orbit here, now once again we're seeing most of the moon again, but of course it's decreasing, so it's called a waning, what is that? A waning
Crescent.
gibbous. It's still a gibbous. We're still seeing most of it. Waning gibbous. We'll go back here. At this point,
Wake up for the last one.
yeah, let's see if I can get it on there. That's right. Uh-oh.
No, it'll go. Does it only go forwards?
That's weird. No, it usually does. It's kind of, maybe it's frozen here for a second. Anyway, you get the idea. Oh, a little time delay there. Why is it doing that? Anyway, when it gets to be halfway illuminated on that side, does anybody remember what it's called? Third quarter. Getting to that. Third quarter at that point, and that's again 3 weeks into the month after 21 days. And then when you see the crescent again, this time though it's a waning crescent. Waning crescent. You're going to see that early in the morning. Okay, early in the morning is when you catch a waning crescent. Any questions?
Thank you.
And of course we're back to noon. Yes, go ahead.
I don't know if you've seen things, but like in the day, during the day, sometimes see it.
Sure, yeah, you're going to see the moon. You wouldn't actually see a full moon in the day, but maybe, for example, a gibbous moon where most of the moon, and it's bright enough that you see it in the daytime. So yeah, you'll see, for example, this. If we went back here to a waning gibbous is the kind of moon you would see in the daytime. Sometimes you'll see the quarter moon. It's out a lot. It's out a lot more than you think. When you start looking for it, you start seeing it pretty often. Okay, you want to see this in super fast speed?
Yes.
That's always entertaining.
Oh my god, okay.
There we go. I think that guy's going to get sick. There we go.
It is very
All right. And look, they actually list up the phases right here where you can see it waning gibbous, third quarter briefly, waning crescent, back to new moon, and so forth. Any questions on the phases? Again, it's kind of a fun link, and I have the link in the Dropbox for you to use in the app and the website, or just to help review for the test next week, whatever you want. All right. Let's make Miss Aurelio happy
Yeah.
and do a little bit of marine science here, sort of. About the tides. What causes the tides? Well, there's one word, gravity. Gravity causes the tides. We normally think of the tides as being caused by what object? The moon. And that's true. The moon has the greatest effect on the tides. But another object does as well. The sun. It's less of an effect than the moon, but it does have an effect. So what happens is, guys, when we have the sun and the moon in the same plane, it's like their gravity's working together. It's not like that, they are. The gravity's working together to pull out our water. That's all a tide is. It's our water being pulled out by gravity. It stretches out the water, and we have a particularly high tide. Okay? Because the water is being stretched out. There's going to be a greater difference in high tide and low tide that you're going to notice because the sun and the moon's gravity are working together in a spring tide. What phase is the moon in here? Is the moon in here?
New moon.
That's a new moon. How about right here?
Full moon.
Full moon. So spring tide's going to occur during new moon and full moon. Now we have here in South Florida, we have turtles that come up and make nests on the beach, right? You've seen that?
Yeah.
Do you know that those turtles have evolved to know when the tides are going to be full, like a spring tide? Because they actually won't come up during, for example, a full moon. And the reason is apparently that because of that extra high tide, it's more likely that their eggs will get uncovered when the tide comes up. And then the next morning, the birds are going to have a nice breakfast on their eggs. So instead, they wait for this to happen. What phase would the moon be in here or here? What would those phases be?
Third or
Exactly. Third quarter or first quarter. And look at what happens there. When the moon is at a right angle to the sun, it's like its gravity is working against. The gravity is working against each other, and the tides are not as extreme, and their eggs are going to be more protected. The water's not going to come up as high and uncover their eggs. So they purposely lay the eggs during first quarter and third quarter. Any questions on that? Speaking of Miss Aurelio, she prefers to be called the Tampster. Okay, so please address her that way from now on. Thank you.
oh well.
All right.
I see what that.
Yes, please do. She'll know exactly where it's coming from too. All right. Hey, here's that word again. One more topic today, just one more topic, and then we're done. Sidereal. Sidereal. Now, a sidereal month is how long it takes the moon to orbit the Earth. Now, what I'm going to do, I think I'll have Avi here. I'm going to have Avi calculate later this hour the exact time it takes the moon to orbit the Earth. And it's not a difficult calculation, actually. You plug into Newton's law of gravity, or you could start with Kepler's third law. And you find out that it actually takes the moon 27.3 days. So he's going to verify that for us. 27.3 days to orbit the Earth. Does that look like it matches up with a month? No, it doesn't. There are no months that are 27 days long. But the physics says that's how long it takes the moon to orbit the Earth. Of course, we don't base a month on that. We just said a minute ago we base it on the phases. And the time between phases is 29.5 days, or what we call a synodic month. That's the one that's important. That's the one that we base our time on, we base our months on. But the question is, why is there a difference between the two things? And the answer is the same reason there's a difference between a sidereal day and a solar day. Because while the moon is orbiting the Earth, what is the Earth doing? Orbiting the sun. So because the Earth is moving, it's like the moon sort of has to catch up to us, to line up again. I'm going to show you on the next slide how this works. This next picture, iBook folks and app folks, this is in the Dropbox now. Make sure you get this one. This is a great picture to illustrate this.
Does sidereal
No, not at all. Good question. Okay, take a look. Moon, Earth, Sun. What phase is the moon in here, by the way? That'd be a full moon. That'd be a full moon. So watch. Look at where the moon's at in relation to the Earth. It's directly to the left of it. By the time the moon makes its orbit, and we get to here, do you see that the moon is once again to the left of the Earth? How long did it take to make that complete orbit? Careful. How long did it actually take to go from here to here for the moon? 27.3 days. That's a sidereal month. Here's the problem. Moon, Earth. Is it a full moon again? No, it's not. They're not lined up. So what happens is, since the Earth has moved, the moon now has to continue a little longer until it's lined up again. That's the full moon. You tell me, approximately, how long does it take the moon to go from here to here?
2 days.
2 days. Very good. That extra 2 days is why our months are not 27 days long. Our months are closer to 30 days long because of that extra, 2.2 days or whatever it is. You guys think you understand that? Now, film crew, I want a couple films from you today. I want a film of procession explaining that, and I want a film of this at some point explaining that when I can help go over this again with you. That's an important one, and that's an important one to get into the website and into the app and into the iBooks and all that. Any questions on today's lecture? Thank you guys for listening.